Hello, everyone. This is Stephen Massa with the Water Environment Federation. I want to welcome each of you to the Making Dewatering a Piece of Cake e-showcase. Before we begin, I would like to quickly review a few logistics. During this webcast, while you cannot speak directly to the presenters, you will have an opportunity to submit questions by typing your specific question into the GoToWebinar pane that appears on the right-hand side of your computer screen. We will be accumulating questions and directing them to the presenters at the end. The PDF PowerPoint presentations are now available for downloading at WEF's website and are currently available in the Handouts pane of the GoToWebinar panel. This link was included in the GoToWebinar reminder email sent an hour before the webcast and will be included in the follow-up email sent 24 hours after the webcast has ended. We will be recording this e-showcase. The recording link will be available on the webcast website 24 hours after the webcast has ended. Please note that PDH credits are not available for this event. Please note that today's event is an e-showcase and does not necessarily reflect the views of the Water Environment Federation. If you have any additional questions after the webcast has ended, please email webcasts@wef.org. Today's speakers are Mike Jagger and Carrie Gabriels. Mike is a product manager and Carrie is a laboratory manager at Evoqua. Mike and Carrie, I'll hand it over to you.
All right, thank you, Steve. Today we're going to talk over the dewatering overview. We're going to then look at a technology overview, and then we're going to go into a rotary press breakdown on the applications that it can function well in, the specifications of these units, and then some information about Evoqua and our quality assurance programs, and then we'll give you a chance for some questions. All right, dewatering. I think most of you probably know what dewatering is, but just to cover this a little bit, it's separating suspended solids from a liquid. Doesn't necessarily have to be water, it can be other liquids, but it has to be suspended solids. Dewatering is not used to get dissolved solids out of liquid. That takes another process. Once the dissolved solids are precipitated, though, then dewatering comes in to get rid of the precipitated suspended solids. The separating a solid from a liquid is quite often, as you see here, used on municipal waste or other wastewater, but it is also used quite often in processes, chemical processing, fertilizer, food and beverage for getting purifying liquid sugar, get particles out of there, things like that. So not just waste. Quite often, the filtrate is the product that the customer is looking for. So the liquid, maybe like in a winery or chemical or something like that. The filtrate is actually the product, and that the customer can make money off of. Or the sludge could be the product. Again, if you're talking to mining in particular, the gold or the silver that is being separated is the product. So there, it's worth lots of money. Again, chemical, pigment, and dyes. A lot of times the pigments are dried and used as the product. Or it could be that there is no product, especially on a wastewater application. The sludge is going to a landfill or going to be land applied. It's not a product. It's just it's a byproduct that needs to be getting rid of, and then the liquid, which is usually water in that case, is reprocessed, recycled through the system, or sent on to the local wastewater municipal plant. In that case, what they're trying to do is lower your hauling costs. Liquid waste being hauled to a local municipal plant can be quite expensive to move by truck, or whereas dry solids, much less weight you're not transporting the liquid that has to be removed anyway, so the hauling costs are greatly decreased. Technology used to dewater, got the 5 of them here that Evoqua has been involved with: the belt press, the centrifuge, filter presses, screw press, and rotary press. These are mechanical separation devices. Either use pressure or, in the case of the centrifuge, that just exactly like it sounds, uses centrifugal force to separate the water from the solids. A screw press squeezes with a compression screw, an ever-decreasing screw, and then a rotary press works by pressure differential in the chambers. Filter press is also pressure differential between the chambers with a filter cloth. Besides these, there's a myriad of other equipment you can use, going all the way from the old drying beds at the municipal plants to geotubes, vacuum belt presses, vacuum drums, and volute presses, also a type of screw press. So multiple technology. What's best? Well, it depends, again, as all of us in the dewatering field know, it depends on the application and the chemical processing that you're using in front of it. So we don't say that there's one best technology, but there is usually a best technology for an application. And that's going to lead us into talking about the rotary press and its applications. So a rotary press works by transferring the sludge in through a low positive displacement pump and having it mix after the pump with a polymer. It could be some other chemical additive, something to coagulate it, but the fact is that it usually takes some sort of chemical on a rotary press to condition the sludge. Not always necessary, again, depends on the application, but where we're finding this used is in a polymer conditioning type. So we're going to go into our polymer unit. Again, this is just really a diagram, but there's an aging tank. There's some sort of aging device usually on a rotary press. The conditioned sludge goes in between the plates, and that we back pressure that a little bit with a plate on the exit, and that causes a differential pressure to atmosphere, so the water wants to exit out the plate to the atmosphere, which is, of course, contained in a drain and usually brought back to the head of the plant. Some places this is okay to discharge directly to the municipal plant. And then the cake out is, depending on the application, much lighter, not powdery, but pretty dry, so that it can be transferred, either land applied or transferred to the landfill fairly easily. A rotary press, Evoqua's rotary press, a completely self-contained unit, so it has the polymer system on it. The feed pump is contained here, totally controlled by the PLC, and a metering pump for the polymer that feeds into the rotary press, and the sludge is discharged out the top chutes the filtrate is discharged out the bottom. As you can see, the footprint of the rotary press compared to some of the other types of dewatering equipment, much smaller, fits on a, like we said, a skid, can drop into most any room that has had pre-existing dewatering equipment in it and leaves quite a bit of room. Where it especially great is if a municipal plant or industrial plant has to expand and they've been using dried beds or rotary or geotubes, something like that. Even if there's a belt press or a screw press in there, we can take the belt press out and fit a couple of rotary presses in there, or just have extra room in the existing plant. But also building new plants, this allows us to greatly reduce the amount of infrastructure that needs to be built compared to other technologies. And the operation maintenance of a rotary press is just, it's automated. We can automate the startup. We automate the shutdown. It can run 24/7 if it needs to. We don't need an operator, except we advise an operator to be there at the startup to make sure that the polymer mixing is correct for the sludge that day, because it does vary and it could need some adjustments on the chemical and stuff. And then we do have the ability to detect the faults in the machine and relay that to a mobile device. So if the operator's in another part of the building or even outside of the building, we have installs where the operator is also the poor guy who's got to mow the lawn and be outside stuff, and we've been able to send faults and stuff over to them while mowing the lawn. So it's a great device to minimize the amount of operators needed in your dewatering house. And then, of course, we have the ability to program with the PLC, and the clean in place system runs automatically. No one needs to be there to run that. We don't run constant wash water like a belt press, but we do have periodic water wash to keep the screens clean. Water One is an Evoqua advantage where we can actually remote monitor if that's something that the customer would like, and then we can watch the faults and send out local service teams if needed, or contact the water system operators, let them know what's going on and what needs to be adjusted, and that can be from a simple chemical adjustment to servicing the machine if there's a broken part or something like that. And we also keep all the data and just really relieve the plant of any need to worry about their water. We can take that over and just really charge the customer for actual water. They're not responsible for the machinery, the upkeep, or the warranties. The rotary press on the actual press has very few moving parts. As you can see there, it's about 8 of them. There's seals and stainless steel inside. It really doesn't need much maintenance. Very little is required. The machine operates at only 1 RPM, so the rotation is very slow. So the wearing is greatly reduced. There are no internal bearings in in the machine, and there's no need for complete machine rebuilds. The part goes bad, an operator can just open it up from there, remove the part, slide the new part in. It's not extensive factory work or send the unit back like a centrifuge, or not nearly the bearings or rollers like a belt press. Internal housing is easily accessible with a door, so they can turn the machine off and open it up and view most of the moving parts from the door. All right, so what's the cost of operation compared to others? The electrical consumption, usually smaller horsepower, one motor on the main drive, compared to a belt press, which usually has one or two, and then the centrifuge, which has a extremely large motor and spins at 3,500 RPMs. So the electrical consumption is the lowest of these. The water consumption, again, a belt press is constantly washing the belts. Centrifuges are used quite a bit at the end of the process to clean, so the rotary press consumes about 6 to 8 extra gallons per minute of water. That can be recycled water as long as it's filtered to under 200 microns. Okay, and then polymer consumption on a rotary press is about medium compared to the polymer consumption on a centrifuge, which is quite high, a little bit higher than a belt press.
So as Mike finished up talking about the rotary press and how it actually works, what the rotary press really works well on is the difficult to dewater applications that require constant sludge conditioning using polymer, or as Mike mentioned earlier, some coagulants and chemicals of that like. On this slide, you can see some of the highlighted applications of the biosolids, DAF, animal waste, primary waste, all of those belonging to municipals, and the biological applications. It's also used in food and beverage processing, beer and wine, typically on the waste side of things, and then also the pulp and paper industry. On this next slide is going to be some typical performance of the rotary press. Sludge is definitely an application specific, is very application specific and can vary widely as far as the results go. And most of us know that the average cake solids, cake dry solids, and the feed solids can vary quite a lot depending on which application you have yourself. So this table is just going to show some averages for those industries indicated. And because the sludges in our world are so difficult to dewater and are so specific, we will be offering lab testing in the plant here to see if your application is a good fit for the rotary press or not. As you can see, there's a couple of applications on here. For instance, the anaerobically digested sludge, if you give it a feed solids of 1 to 4%, you should see on average a filter cake dryness of around 20 to 22%, with an average polymer dose, active polymer dose of around 10 to 12 pounds per ton dry solid. And you can see also in our brewery applications, the filter cake is not quite as dry due to some of the solids that hold on to their moisture. And also down on the bottom, you can see it works in the pulp and paper industry, which is very depending on the specific waste stream that is being run at the pulp and paper. And also manures, swine, chicken, All of that has been tested and worked on the rotary press itself.
All right, so again, like we showed you before, we have a skid-mounted unit that is completely self-contained. Again, we like to say it's plug and play, so it's a matter of hooking up electrical and hooking up the inlet and a wash water source. Again, that can be recycled filtrate as long as it's filtered and cleaned. The units are expandable. We can have one press on a unit. You're seeing a unit here with 2 presses on it, and they're expandable up to 4 units per thing. They come in sizes of 24, 36, and 48-inch presses, so we can get quite large, especially when you go to 4. We could run 5 GPM all the way up to 260 GPM. The thing about the rotary press is it can run 24 hours a day, but it also can be shut down and turned back on quickly and efficiently. Turn off, it'll go through a clean in place run, and then be ready for the next run whenever you want that. So that it can run for 4 hours and be quickly turned off and turned back down. It's not a batch unit. It runs off a continuous stream. So it's very nice for those with irregular amounts of sludge. No big storage tank is required. Take the sludge directly off your clarifier or other thickening unit. The compact footprint fits anywhere another dewatering device fits, so easily replaceable. Again, the plug and play just needs an inlet to start and a place to deposit the filtrate. Very easy operation. It's a matter of a couple of switches, and it's got sensors that control the flow and the polymer and the mixing. So once the mixing is set, it runs on its own. It's a completely enclosed system, so odor is easily controlled from the time that the sludge enters the system to the time it comes out the discharge thing. There's no contact with the outside air, so odor is rarely a problem, but can be again drawn off the machine if need be. Also, so without the skid, if the existing infrastructure has feed pumps, polymer systems already there, we can sell a standalone press. Also, if a EPC intends to integrate it into their system, very easy to do that. And that allows the EPC to control the feed and polymer and everything. Definitely can hook the PLC into the customer SCADA system to be controlled from a remote location. Particularly, this unit is not a problem with that. It's completely self-contained. There's no safety problems for it to be running on its own, because all the moving parts are contained inside the machine, so it's extremely safe for operators. Nowhere really that they can stick their hands and get into pinch points and stuff. Runs at an extremely low operational speed, less than 1 RPM mainly, so that's also very safe and low wear and tear on the machine. Can run for many years without service or parts replacement. Evoqua is a service, full equipment provider. So everything leading up to the press, or especially outside of the press for sludge management, we can sell thickeners and clarifiers. We have conveyors of all sorts, belts, screw, helix, for discharging over short distances or long distances. Then also dumpsters, if you've got a forklift, got a self-dumping dumpster, very convenient to put under a conveyor for these, or just directly under the chutes if the customer wants to handle it that way. And also platforms for raising the unit up above any of those accessories.
Beyond all of the accessories that are offered with the rotary press, Evoqua does offer a full support services division that includes lab testing, as I mentioned before, pre-sales, working to size the equipment and working to see if the application will actually work on the rotary press. This includes a lot of benchtop testing and some jar testing. And then we also provide field service support that can include field service visits, emergency 24-hour support. And Evoqua also supplies or has available same-day shipment on many parts and services that are in stock. And also the aftermarket department also works with our engineering as far as equipment retrofits and upgrades to your system. Evoqua is very well, has a very wide range of people that can assist setting up a system. As you can see down below, the lab testing requires very little of your sludge. But yeah, that's as far as the support.
All right, so that's the end of our presentation. So we're at the question period. So I think if you have questions, you just take them into the question thing. So the first question is, can the rotary press be running around the clock so its size is minimized? And the answer to that is yes, absolutely. It can run 24/7 with extremely little operator watching it, so it would just be alerted to the faults. And again, you wouldn't expect there to be any faults unless the incoming slurry really changes, or there's some problem with a part on the machine. So we can offer a lower size because the throughput in 24 hours would be much greater than, say, just an 8-hour day for a 9 to 5. And then the next question, what styles of feed pumps can be used with the rotary press? This is the rotary press uses a positive displacement lobe pump, sludge feed pump. It's pretty much neat to maintain the pressure constant, and the lobe pump is what we found is the best. I got a question for Carrie. What is the quality of the cake compared to decanters or centrifuges?
As far as decanters go, the cake is going to be, it will pass a paint filter test, so you will not have any free liquids that are going to be dripping out of the filter press. And so that, compared to, you know, the decanters, obviously it's going to be less liquid. Centrifuges, the cake gets drier than the centrifuge as well.
Okay, another question. What are the most common parts that need to be replaced? Really, that's just the scrapers. There's some brass scrapers inside, although they have a life of 5,000 to 10,000 hours, depending on the application and how gritty it is. They are relatively inexpensive to replace, and because they can easily be reached by opening the unit there, it probably takes an hour or two to do that when they need to be replaced. The other thing that has to happen periodically is changing the oil in the gearbox. That's about every couple of years per the manufacturer's advice. So again, not maybe a couple hours to do. So really, we're talking about maybe 5 to 6 hours a year to do the maintenance on this. The other stuff is it is a clean in place. So, but I mean, you need to make sure that that things are clean and periodically checked. All right. And what is the average lifetime of the press? Haven't reached that yet, but these are built to last well into over 20 years. They're, like I said, they spin at 1 RPM, and they don't have a lot of wear and tear on them. That just with the cleaning and everything, they just should not wear out quickly at all. I would say much better than a belt press or a centrifuge, which moves at a lot higher speed and has a lot more abrasive problems. And then we have one more question, and that is, what is the polymer consumption of the rotary press?
So the polymer consumption is going to be application dependent, of course. And can we go back to slides? I can't go back. As we showed on that table earlier, the general average polymer consumption is, you know, between 8 and 15 pounds per ton dry solids. I'll call that, you know, a good range. You know, and that is active polymer. That is not neat polymer.
Okay, a couple other questions come in. Can the rotary press be rented? Yes, we can. Evoqua has a large rental program with most of Evoqua's equipment can be rented, and the rotary press definitely included on that. We put it on a trailer and get it to the customer. Is the rotary press suitable for flocks? Is it really sensitive to shear?
It is not sensitive to, well, that's part of the lab testing, and I will say that the flock has to be fairly stable, which is why there is the aging chamber or aging tank or the mixing chamber ahead of the press itself. So the flock should be fairly large and fairly stable as well. The light, fluffy flocks will be pushed through the screen itself. It will take more time to build up the filter cake in the chamber.
When used for manure digestates dewatering, do you need a fiber removal step upstream?
I do not know the answer to that question. Depends on how big the fibers are, I would guess, is the answer to that one.
All right, we'll find the answer to that and answer
Six,
that at a
yes.
later report. Okay, I think that's it for questions.
Okay, well, thank you guys for your time today. Thank you for your presentation. Thank you to everybody for attending. Be on the lookout for the follow-up email that will go out about 24 hours from now that will include a link to the webcast recording as well as the presentation handouts. Thank you all again for attending today, and we hope to see you at our next webcast event.
I'm still on the line.